I put as a subtitle, when a road is more than getting from A to B. I was talking to some of my colleagues out here who also talk about mobility today, and there's a lot about traffic and cars and vehicle and interesting stuff. But the road, not everybody thinks about, surprisingly enough. People are saying, well, when you start talking about asphalt or the road, we're thinking about it, but this is the thing you drive over. Yet not everybody is thinking about it and how important it is. So I'm going to talk a little bit about what it is, because it's changing over time, what a road is, and then why it's very interesting for you to know more about it and where we are at. First of all, good morning, because this is very early. Some of you have already been here for a while, but for me this is, even though I have small children, this is still early to be presenting. I'm Professor Highway Engineering at KTH, and I'm responsible for a competence center, Road to Science, which is working a lot with industry to make sure whatever we do at KTH in the academic front is connected to industry involved. And I want you to think a little bit first about something else, your phone. This is the way the phone looks today, right? And what do we use it for? If I forget my phone, I forget almost my entire life today. What did this thing look like 50 years ago? We didn't even have one with us, right? So it was just a thing I even remember, not for 50 years ago, but when I grew up, when you took it from the wall and it had this cord around it, and you used it to make phone calls. Now think about the road. What did the road look like 50 years ago? More or less. And what does it look like today? Not that different, right? So we can say, well, what is the technology? Why do we need research? And why is it interesting to start with? Well, I hope I can convince you. A road, of course, is something we drive over. Often it has asphalt, it has concrete, it has gravel, it has different layers. But at the end of the day, it's something you want to have a comfortable drive over. So if I ask any of you what's a road, you probably will answer me it's something I drive over to get from A to B. But what if you think about this long surface, there's a lot of infrastructure everywhere. Why? Well, we have sunshine over it, we're driving over it, so there's a heat generation which now is disappearing. What if we would capture that heat, for instance, and we would use it to lighten the areas nearby, or to heaten the roads when there is snow in winter times? This energy harvesting, as it's called, is a very interesting concept. Well, what about electrical vehicles and autonomous driving that we're talking about, and some of the speakers in this session will be talking about? We're discussing a lot, if you have an electrical vehicle, this could be a truck or a personal car, and we want to go down in the battery, or we are a little bit afraid that the battery's capacity isn't long enough. What if we could charge our vehicle while we're driving, because there's something inside the road? So electrical roads, or elvägar in Swedish, are becoming very, very serious topic of research. And that means that we are now building a road which no longer is just these layers on top of each other, but it has an integrated structure in there. From a material point of view, this is very interesting, because you have to make sure you have optimal materials inside. But as a structure, it now is a very complex structure that doesn't only have civil engineering materials inside, but it also has ICT components in there. It can have coils in there. It can have foreign units that are supposed to communicate now with the vehicles, be it to charge it or to guide the road. What about sensors inside of the roads, which we can talk about? Where we are talking about maybe the road is twittering itself when there's a crack coming in a year or in a month or in a week's time, because the road knows we have put stuff inside, so we know what's the stress and what's the strain level, so we can say, well, maybe we need some repair a month from now. So we are moving away from ad hoc reparations. So that means we can optimize when we're going to modify a road. And that's very good for traffic, and it's very economically good, because then you can optimize also materials. When we talk about sustainability of the road, anything you improve in terms of better knowledge about the road and the structure, where you can engineer it as an object rather than rely on empiricism, is good, because that means you can much sharper choose which materials you want to use. You can much sharper design it, so you don't waste a lot of materials. You don't waste it by doing repairs that may have not been needed. But even when you talk, before you start building the road, the materials and the process how we are creating, for instance, asphalt or concrete, the transport associated with these materials, they in fact contribute a lot in the CO2 emissions and other greenhouse gases that we have today. So the design of our materials in a greener way, in a more sustainable way, is very significant. Now, as we are talking about a bulk material, a civil engineering material, where we need a lot of material, it is not as highly engineered material as some of the clean room materials when you talk about chips. But we need a lot and a lot of it. So even if you make a percentage improvement because of the sheer bulk of it, that's a huge impact. So a lot of the research we're also looking at in the design of the materials, how can we optimize the materials in that way. So before I talk to you more, I want to show you a little film. Let's zoom in a little bit on where we are today. Infrastructure, everybody understands, is crucial to society. And infrastructure, we are talking about very high loads in Sweden. We have a huge industry of transport of wood and other things. We have integrated transport, different kind of infrastructure, and all of these, they need, in fact, a road top on top of the structure. So even if you have a bridge, you need an asphalt or a concrete layer on top. Now let's look a little bit in the future. Where could we be in the future? What could the road be except for transport and making sure we can sustain the transport that we need? We probably still have cars and trains. There has been a lot of visions of future where we're just flying in the past, and we're still not doing that. So, but what if all our roads now will be green? All the materials that we're using are green, the production is green. These no longer are reliant on fossil fuel based materials. We can actually harvest energy from our roads. We can plug in our houses, because now we have energy harvesting, which we save there. We can use it for lighting. When there is a crack, as I was saying, the road is calling you, and there comes the repair. Think about your car now does that already. You already get an announcement from your car that you need to go to the dealer or to the garage to have a repair. Now we look in academia, but also in industry, we look at our material closer. In academia, that goes to extremes as using neutron scattering and very fancy type of equipment to understand the material better. But we also get a lot of cores from the road, where we're making 3D models, so we're trying to understand what has gone wrong inside. And one of the driving mechanisms for innovation that we don't have in infrastructure is, in fact, that the copyright sign, we cannot patent our things, and I will talk a little bit more about that as well. Data that we get, we have all this heavy equipment that's building our roads, that is collecting data for us, which we could use. And so big data and how to handle this data is becoming also a very important topic. Most industries, they have a very logical way of why innovation is happening. A lot has to do with patents, and that people can invest, companies can invest, institutes can invest in investments or innovations in a topic, and then they can get money out of that, so that the investment that they spend, they can get back. Now, the problem we have, that infrastructure is mostly state-owned. In Sweden, about 1/3 is owned and maintained by the road authorities, about 1/3 by the local municipalities, and 1/3 private. So 2/3 is owned by the state. That means we have state procurement, and that means we have a whole set of rules that is very difficult to have patented interventions in there. It is not so simple to do that when at the end of the day, when it goes wrong, the problem is back at the state. So why would any individual partner invest in integrated technology, in new kind of inventions, which makes you give a niche over another company if you're not able to use them? So that's a major issue that we are trying to overcome together with our partners. How can we make these very complex integrated structures, which roads will be in the future, in a way that it's valuable for the partners that are investing it? It can be relied on by the state and by society, that they will work. And that means that if it fails, we need to also know who is responsible. So it takes patent inventions? Can we in fact have solutions and new knowledge which we could sell abroad, which is owned by certain partners? That's really important. And then do we know, if we have this very complex integrated structure, who legally is responsible if something fails? These things are also very important, though they don't focus on the technical aspects of the road. They will support the whole development of us being able to have new inventions and new solutions for sustainable infrastructure. When I spoke about, when I said the title was Connecting People, it is connecting people. It always has been connecting people infrastructure, because we go from, it allows us to go from one way to another. But just like the phone, we were saying, we are connected to our entire family and to everybody. While we are somewhere else, we can connect all the time with everybody. The roads will not be that different. Rather than geographically connections, we will, the way we're going to be engineering our roads and our infrastructure system in the future will get more and more integrated and complex and cross-disciplinary. And I think that is a realization which we have come with in academia, but also with industry. In Sweden, you have more and more total turnkey projects where all the partners have to work together. And it's a project, not just delivering a project, but also you have to maintain it. So knowing what's going to happen with the road 10, 15 years from now is becoming very important. With that comes an incredible need for knowledge. We can no longer rely on the way we did it 40 or 50 years ago. Even though I said we are no way near this. We can no longer say 50 years ago, we did it like this, it was a couple of layers on top of each other. Okay, the traffic is a little bit heavier, we'll put a little bit thicker asphalt layer. If you are going to now have a surface which you're providing to society, like energy, or like the roads need to tell society when they're going to fail, or the whole mobility, so the electrical vehicles or the autonomous vehicles rely on data that is coming from the road. That means we need to know at any time what is going on. And that empiricism doesn't help with, because that's looking back the way it was, but the future is very different. So when we talk about education, what does that leave us saying about the future civil engineer or the future pavement engineer? Those that have to be able to design the roads. They no longer can look back at their colleague that was 40 years ago at the company that says, well, we do it the same way we always used to do it. Just follow this kind of guidelines and it's okay, it's safe, we don't run too many risks. No, because now the demand may be a completely new kind of material, because that's much more sustainable. It may be an electrified road, or it may be a person that needs to give the guidance to the company. Do we dare to make this structure which is 20% thinner, which gives us a huge gain in terms of environmental gain, economic gain, for society it becomes a new structure which has a gain. Do we dare to do that? So we need to educate, and we are educating our future engineers to be able to work with the chemists, to work with electrical engineers, to work with people that can have to make an integrated structure together. As you look at the way it used to be, often these kind of roles are split between companies or departments where they have different responsibilities for different layers. This no longer is an option when you talk about an integrated cross-cultural or cross-disciplinary structure, which is knowledge. Once we are able to get our hands around being able to engineer such an integrated structure, that is also knowledge you can sell in other countries and in other places. So it's no longer simply a domestic affair to build a road. It becomes something which is integrated in society, but also something that you can export to other countries, because it's not simple how to deal with these different things. And we haven't done this 40, 50 years ago. We're getting now in the domain of this. Is highly integrated with its users. So how can we now make sure that we provide the services we need? How can we make sure that we design, plan, build, maintain these structures in a sustainable way when we're dealing with all these different partners, which is many, many more than we had in the past? So roads, though it is something simple you drive over and as a structure is quite flat, are becoming extremely complex and more interesting. So next time you drive over a road, please think a little bit about it's not just simple a flat layer you drive over, but it's something that can provide services to you as well. And as it is so much of it, infrastructure can play a very, very important role in society beyond just moving from A to B. Thank you.